Hello, friends. Asterisk, how did our Earth come into existence? Asterisk, how could this beautiful blue planet, full of life, form out of seemingly thin air in the vast emptiness of space? This question has fascinated scientists, philosophers, and thinkers for centuries. And today, I shall present this very intricate subject in a quite straightforward and interactive way, using facts and evidence along with different theories. So, let's start. Now that we have been talking about the moon, it is time to circle back to where all of this started, the Big Bang. It was a little over 13.8 billion years ago when this incomprehensible explosion helped create the universe. What? This was an explosion of matter, but rather of space and time itself. This singularity expanded and formed into everything we see today. Protons, neutrons, and electrons, three sorts of subatomic particles, soon appeared. Hydrogen and helium, the lightest and most abundant of the elements in the space, were the result of the coagulation of these subatomic particles. They went on to continue aggregating into baryonic gas according to gravity's pull over millions of years and gave birth to stars. The process of nuclear fusion within the core of the stars resulted in the creation of heavier elements such as carbon, oxygen, and iron. It's a little like baking a cake. The first stars of the universe were, in essence, kind of like ovens that baked heavier elements, which they then went on to be the ingredients for planets like Earth. Fast forwarding into about 4.6 billion years ago, our solar system began to take shape from one huge molecular cloud of gas and dust. This cloud, now referred to as the solar nebula, collapsed under its own gravity. Out of that cloud, which was collapsing upon itself, a young star, our sun, ignited. The remaining gas and dust began orbiting around it in a flat disk. Over time, within that disk, bits of material collided and stuck together and became planetesimals, small bodies made up of rocky materials. Some of those grew larger through a process called accretion and turned into the planets we see today. They estimate that 99.8% of the mass in our solar system is located in the sun. Everything else, the other planets, moons, asteroids, comets, etc., adds up to only 0.2%. Focusing on the Earth. The Earth began as a hot, molten mass of material, formed by the collisions of countless numbers of planetesimals. These collisions would have released a lot of energy since newly collided material was heating the young Earth. Over time, the heavier elements such as iron went down to become the core of the Earth, while the lighter ones rose to the top to form the crust. By this process of separation, the Earth developed its layered nature, the core, the mantle, and the crust. About 4.5 billion years ago, a Mars-sized body known as Theia smashes into Earth. Not only does it resculpt Earth, but it also makes way for the moon to be formed from debris. Experts claim that such evidence favors this theory, based on the lunar rocks that were brought aboard the return trip of the Apollo mission, since these have similar isotopic composition with Earth's crust. How did the Earth change from a hot, lifeless ball of molten rock to the living, breathing blue planet we see now? At least partly, it came down to two major factors: atmosphere and water. Earth's first atmosphere was made of hydrogen and helium, but that was all blown off by solar winds. Volcanic eruptions then exhaled gases including carbon dioxide, water vapor, and nitrogen to compose a new atmosphere. To this day, this is still a topic many still argue on the origin of the water in Earth. Many scientists agree it originated from comets and asteroids that bombarded Earth in the form of frozen particles. Yet others claim that it was formed here, released by volcanic activity. In 2020, Scientists found water molecules on the moon, potentially raising the possibility that more areas of the solar system could have water as previously believed. The nebula hypothesis represents one of the oldest and most widely accepted theories on the origin of Earth, which states that Earth originated from a solar nebula. The capture theory implies that Earth is a cosmic body, formed somewhere in the universe and captured by the sun's gravity. New breakthroughs such as AI and machine learning are beginning to allow scientists to be able to model planetary formation with much greater precision than before, revealing insights about exoplanets and what they might be like compared to Earth. AI brings about an entirely new perspective toward planetary science. From instant analysis of thousands of images at one go to simulating intricate processes, it is unveiling patterns that we could never have picked before. AI has already helped scientists identify Earth-like exoplanets far away in star systems and given us clues about the uniqueness of the formation of Earth. Machine learning models are also coming to the aid of scientists studying asteroids and meteorites to gain insights into early solar system phenomena. So, friends, from thin air, or rather stardust, Earth's journey is a story of chaos, collision, and incredible transformation. But this story reminds us of something really essential, something so important to keep in mind. Our planet stands alone. It is unique. Its ability to sustain life a precious, even rare, gift. The more I learn about the origin of our Earth, the easier it's to forget our responsibility toward this stunning blue dot in space. After all, it's home. Keep on being curious and keep learning. Thanks for watching.